In chapter 4, we started to talk about quadratic functions. And so we need to know fundamentally what a quadratic function is. So what is a quadratic function? Well, a quadratic function is something that has the root of an x squared. So y equals x squared, that is our parent function. That is our parent function. That means that we can see an x squared somewhere. There may be some other x's, some other numbers, but we can somehow take this function right here, and change it. And that's where we're starting. So initially, what we need to be able to do is, if I give you an example of y equals 2x squared, so for the first part of your homework, you're needing to fill in a table x, y. And if I give you some x values, you just need to be able to plug those in. So if I plug in 0, I get 2 times 0 squared, which is 0. If I plug in 2, I get 2 squared, which that gives me 2 times 4, so that is 8. 4 squared, that's 2 times 16, that's 32. So in the first part of your homework, all we're doing is plugging in some values for those tables. In 4.1, we also started to go over the standard form. And the standard form of a quadratic is this: y equals ax squared plus bx plus c. And from this form, we know a couple of things. We can look on page 237 in the key concept box, and there are listed 4 bullet points. So our first bullet point talks about a, so our leading coefficient. It's called the leading coefficient because x squared is the biggest x term, and it's in front of that. So that's our leading coefficient. And it says if a is greater than 0, it opens up. So if it's positive, it opens up, makes a nice U. And if a is less than 0, it opens downward. Opens down. And gives us a nice kind of N looking thing. Alright, cup versus a hill. That's a cup, this is a cup, and this is a hill. Alright, and bullet point number 2, it says looking at a again. So if the absolute value of a is greater than 1, so if it's -4, if it's 4, if it's -2, if it's 2, if the absolute value is greater than 1, then it gets narrow. Or it gets narrow. Which we've talked about it as a vertical stretch. I think of that if the number out in front is bigger, I'm thinking of things getting bigger, so I'm thinking vertical stretch or horizontal shrink. That's how it gets narrow. Okay, and if the absolute value is less than 1, it's the exact opposite. It gets wider. So it looks like a big old ball versus something very thin. So that's a vertical shrink, and a horizontal stretch. Alright, our third bullet point, this is something that we're going to need to memorize from this form. This is for standard form alone. The opposite of b over 2a, negative b over 2a, that gives me an x value. That is our axis of symmetry. So if I have a parabola here, here's my axis of symmetry. On that axis of symmetry is my vertex. So if I plug that back in, for vertex. So this is my x value for my vertex. So I would have a coordinate pair then. So that's my x, and then I would need to find my y. That's what I plug back in for. Alright, and our last piece of information. Anytime that we've been able to graph something and we plug in zeros for x, that's going to give me my y-intercept. So when I plug in zeros, that eliminates this term, and that eliminates that term. Those both go to 0, so my y-intercept is simply just c. 0c is my y-intercept. So if I go to an example, let me erase some things here. Alright, if I go to an example, this is guided practice number 2. If I go to an example, let's start with the first bullet point. So the first bullet point, I want to determine if it opens up or down. Well, A is negative, opens down. So opens down, and what is the value? Technically, this is a -1. Technically, that's a -1 right there. So it doesn't really, it's not greater than 1, it's not less than 1. So it should have kind of the same proportion. It's not stretching or shrinking any. It may just move. All right. And then let's see here. Our -b over 2a. Well, if I'm putting this completely in standard form, what is b? Do I have an x term there? I don't. That's 0x minus 5. So -b is -0 over 2a, which that's 2 times -1. So -0 over -2, that just gives me 0. So my axis of symmetry is simply just x equals 0. Well, let's find my vertex. What did I have to do? Plug it in. I needed to plug it in. So let me go ahead and plug 0 in. When I plug in 0 in for x, this term disappears. So I get y equals -5. So my vertex is 0, -5. Well, let's see if I can find my third piece of information, my y-intercept. What do? I need to look for my c. There. So my y-intercept is 0, what is my c? -5. Well, looks like my vertex and my y-intercept are the same. So if I were to graph it, 0, 1, 2, 3, 4, 5, and keeping in mind it opens up downwards, it's going to kind of look like something like that. And I would find some x and y values and go ahead and plot some points. So I'd pick -1, -2, 1, and 2, and be able to graph it that way. Alright, another example. So another example in standard form. This fits the bill. I do actually have an A, a B, and a C this time. So A is less than 0, so that means it opens down. And the absolute value of A, which that's the absolute value of -1/3, equals 1/3, and that is less than 1. So what does that mean? Let's flash back here to what we know. It is less than 1, so it gets wider. It's a vertical shrink. Vertical shrink, wider, horizontal stretch. Okay, let's find our axis of symmetry. That's -b over 2a. So -5 over 2 times -1/3. That gives me a +5 over -2/3. Here I need to do my keep change flip. So I do 5 times -3/2. That gives me -15/2, or -7.5. Okay, so that's my axis of symmetry. And in order to find my vertex, I need to plug that back in. So -1/3 times -7.5 squared. This is where Miss Hlebiczki would use a calculator. And I would find what that value is. So then you would get -7.5, comma, whatever the result of this is. And there's a vertex. Okay, y-intercept. Y-intercept. Well, what do I have to do for that again? Oh, I'm just looking for c. So my y-intercept, 0, comma, right there, 2. And then you should be able to find some additional x and y values in order to graph it. Okay, so let's move on to identifying a maximum or a minimum. So right away, by identifying your a term, you should know whether or not it's a maximum or a minimum. So if I have negative x squared minus 5, that was our one example, I know that it's going to be opening downwards, so I'm going to have a maximum. Max. And if it is y equals 4x squared plus 2x plus 2, this is positive, so I know it's going to open upwards, so I'm going to have a minimum. This is something we didn't really discuss in class. Okay, moving forward to vertex form. So this is now 4.2. This is on page 245. Page 245. Vertex form, it gives me a couple of pieces of information just like my standard form did. So what does it give me? Well, vertex form, it's going to give me my vertex. H comma k. Keep in mind, that's a negative right there. So if you see x plus, 4, that's actually a negative 4 that's in there. Alright, and it also gives me my axis of symmetry. Axis of symmetry, that is always followed by your vertex. So if I know the x value to my vertex, I know my axis of symmetry is whatever that h is. And then, depending on what my a value is, my a value, just like before, if a is greater than 0, it opens up. If a is less than 0, it opens down. Opens down. And we can also remember if I have a stretch or a shrink as well, depending on what my a value is. So looking at this example, I'm looking at my h and my k. What is my vertex? Well, my vertex is -2, -3, keeping in mind that since it's a positive, it's actually minus a negative, so it's -2, which that makes my axis of symmetry. That's a horrible symmetry. Is x equals -2. I'm just looking at my x value for my vertex on this one. And then what is my a value? Do I have an a value right there? It's hidden. It's hidden. A equals 1. So since it is positive, it opens up. Opens up. And is it going to stretch or shrink any? Ones don't really do that. So because it's equal to 1, it should look kind of like a regularly proportioned parabola instead of anything that is stretched or shrunk. Alright, and you should be able to find some x and y values. Since my axis of symmetry is -2, I'm just going to put -2 here, and I do know that that equals -3. I want to choose some points on either side, so maybe -3, -4, -1, and 0. If I find what these values are, I know that since they reflect, so let's say here, it does open upwards. So at -2, that's my axis of symmetry. If I find the value at -1, I should be able to figure out what the value of 3 is. So cut your work in half, only find a couple of points on each side, and then reflect them. Moving on to our last form, graphing using the intercept form. So if I have an equation that is written like this, y equals a, so we've already discussed a about 15 times and what it can do, but this is factored, so I'm going to have a couple sets of parentheses and a value for p and q. So if I have that, I know some other types of information. So first and foremost, I know my x-intercepts. X-intercepts. And those are going to be, keep in mind, when x-intercepts are written as points, it's something comma 0. So it's p0 and q0. Or you can just say x-intercepts are p and q. That is fine. That was a G. All right. So I know my x-intercepts. So if I graph them, I know that I have an intercept over here and an intercept over here. That's 2 points. All right. And let's see here. The second piece of information that I know is the axis of symmetry. Keeping in mind, if I can find the axis of symmetry, then I can find my vertex as well. So let's just say I have this example. All right, here is a P and here is a Q. Well, I know that it needs to reflect over an axis of symmetry. So here's my axis of symmetry. It's going to be right in between those P and Q values. So if I average them, I take P plus Q and average them, P plus Q over 2, then that gives me the x value for my axis of symmetry. Axis of symmetry. And if I have that, then I can go ahead, plug this back in for x, plug in for x, and get my vertex, and get vertex. So then you're going to have an x comma y for your vertex, where this is your x value. Or that's your x value, p plus q over 2. And last but certainly not least, your a. If it's greater than 0, opens up. If it's less than 0, opens down. And just like, let me flash back a couple of slides ago, I would have to multiply this stuff out to, put it in standard form. In this, I would have to, FOIL and multiply that stuff out to put it in standard form. But we should relatively know if it's stretching or shrinking depending on what that a value is. So let's look at an example. Okay, so let's look at these values. Keep in mind it's always x minus, x minus. So if it's a positive, that means that that number there is actually a -1. So what are my x-intercepts? X-intercepts are at 4 and -1. So I'm going to have 4 comma 0 and -1 comma 0. So I can go ahead and graph those. 1, 2, 3, 4. And at -1. So I know approximately, if I'm just approximating, I know my axis of symmetry should be there. So let's figure out p plus q, 4 plus -1, over 2. That gives me a positive 3/2. So if I'm writing that as a decimal, that's 1/2. So 1/2, all right, looks like axis of symmetry. Okay, my A is positive, so I know it should open upwards. Well, let's figure out, it could open upwards starting here, it could open upwards starting here, here, here. So I need to actually figure out what my x and y value is for my vertex. So axis of symmetry, this is my x value. If I plug that back in to my original equation, x minus 4, x plus 1, if I plug in that 1.5, 1.5 minus 4, 1.5 plus 1, I get 2 times -2.5 times positive 2.5. So let's go ahead and multiply these first. I'm just doing PEMDAS, moving left to right. So that gives me -5. Those together give me -5 times 2.5. Negative times positive is negative. So that gives me -12.5. That's my y value. So my vertex is going to occur at 1.5, -12.5. I'm just going to pretend that's all the way down here. So using 3 points, ideally I would want to find another point to really get a good shape, but as long as I have the vertex and a point on either side, it should work out. All right, email me with questions. And last but certainly not least, here's your homework, 4.1 and 4.2, 1 to 21 odd. So that is 11 problems on each for a total of 22 problems. Make sure that you label everything clearly. They should fit on the graph. That's why they adjust and move your X and Y axes, and follow the directions.